Assalamualaikum and a very good day to you. My name is Abdurrahim Benawi, and with my group, Muhammad Zakhiruddin and Muhammad Zulhilmi, are going to briefly describe what we've been told to do for our wireless tutorial, part for the requirement for our bachelor's degree. It consists of a 7 question, and I will be describing the tutorial as fast as I could, but in a clear form. Okay, the first question is what is actually the wireless communication? Wireless communication is a type of the data communication that is performed and delivered wirelessly. Wireless communication generally works through electromagnetic signals that are broadcast by an enabled device within the air. This wireless communication is basically a type of communication where it allows you to make a communication or data transfer to another user wirelessly. It means it does not use any wire. Okay, for example, the cellular phone, it provides connectivity for portable and mobile application in both personal and business. The global positioning system, or the GPS, it allows the drivers to have a better view on where they are heading to assist them in their driving. The cordless telephone set, which is very much in a limited range device, it may not be confused with a cell phone because cordless telephone set are usually being used indoor. Remote garage is one of the oldest wireless devices. It's common use by the consumers. It usually operates at radio frequencies. This is very much the example of the wireless communication we are selected. Although there is numerous example, but we are just select a few of them, which brings a lot of meaning in our daily life. The second question asking is the type of wireless communication. The radio transmission, it is basically an easily generated, omnidirectional, and it may travel at a very much a long distance, and it may easily penetrate building. The microwave transmission, it is being widely used for long range communication, but it is relatively inexpensive. The infrared millimeter wave, widely used for short-range communication, for instance the LAN, Bluetooth, Wi-Fi. Light wave transmission, it is an unguided optical signal such as laser, unidirectional, and it's very much easy to install. This is a list of the frequency that are being used in our daily life, where the highest frequencies that we are using in our daily life is the Wi-Fi and Bluetooth, whereas the smallest frequencies is the FM radio, which is just approximately in 88 megahertz, being compared to the Bluetooth or Wi-Fi, which is approximately 2.4 gigahertz. It's very much huge. Okay, the third question is the electromagnetic spectrum. It is defined as the range of all possible frequencies of electromagnetic radiation. This radiation is defined as the energy that travels, and it may spread out energy as it goes. The limit for long wavelength is the size of the universe itself, which means it's may up to thousands of kilometers, while it is thought to be short wavelength limit as the vicinity of the Planck length, which is very much small indeed. Astronomers who study radio waves tend to use wavelength or frequencies. Most of the radio part of the electromagnetic spectrum falls in the range about 1 centimeter to 1 kilometer, which is 30 gigahertz to 300 kilohertz in frequencies. We are talking about electromagnetic radiation, usually with a small wavelength, which is gamma rays. For the wavelength is less than 10 to the above 9, negative 9. The gamma rays actually have a massive energy, which means it may easily penetrate a solid state. it has more than 10 to the power of 5 energy in it. As for the radio wave, it may does have the highest and the longest wavelength, but it also has the smallest energy in this spectrum. Okay, this is very much graphical representation on the electromagnetic radiation that we are using it nowadays. The radio is basically being used to broadcast. Radio and television is the highest and the longest wavelength, whereas the gamma rays being used in medicine for killing cancer cells, small in wavelength but high energy, which assists them to penetrate a solid object. Other than that, is a visible light make things able to be seen by our human eyesight. Okay, the fourth question is the history of wireless communication. The first wireless network were developed in the pre-industrial age. This system transmits information over line of sight distance, later extended by telescope using smoke signal, torch, and anything. An elaborated set of signal combination was developed to convey complex message with these rudimentary signals. Observation stations were built on hilltop and along roads to relay this message over large distance. In 1895, a few decades after the telephone was invented, a Marconi demonstrated the first radio transmission from the Isle of Wight to a tugboat, which is 18 miles away, and the radio communication was born. The first network based on a packet radio, the Aloha Net, was developed at the University of Hawaii in 1971. This network enabled computer science at 7 campuses spread out over 4 islands to communicate with the central computers on Oahu via radio transmission. This is I'm just going to describe a brief history where it may extend to a long page for the history. Okay, move on. What is the importance of the wireless communication, or what is the main advantage of this communication style? For wireless communication, it is free from wires. No bunch of wire running from here and there. Automatical, instantaneous communication without physical connection. For example, the Bluetooth, Wi-Fi, and the latest one is the NFC. It may cover the long range global coverage. Communication can reach where wiring is infeasible or costly, for instance the rural area, building, battlefield, and outer space. For wireless communication, it enables the user to stay connected, flexibility to connect to multiple of devices. Okay, the sixth question is the main challenges in wireless communication. The most important thing is the challenges faced by the engineers and the physicists in wireless communication is the fading of signal. Where fading a signal in a large scale, which means obstacle. The signal cannot penetrate a solid object, which going to disturb the signal cannot penetrate the object. It may disturb the communication. Okay, the small scale fading are basically being elaborate using the constructive interference and the destructive interference. For the destructive interference, where the peak of the positive peak of the signal meets up with the negative peak of the second signal, which contributes a zero signal, which means you may not be able to make any communication if you are having such situation. This interpass interference basically describe a data which is being transmitted, and the data will travel in a various path. In this section, we just take about three main paths that were using by the data. You may see the output signals, which is the RX, the receiver. It does not represent what is actually the original data, which means the receiver must need set of electronic device to filter out the noise uh, throughout the communication. The available spectrum is limited, where the same frequency range has to be used at many different locations. Regulated spectrum, a single operator owns the spectrum and can determine where to put the transmitter. Cell planning so that interference adhere to certain limit. I may say most of the physicists says that the radio electromagnetic spectrum is very much a natural resources, and it may not be created, but it can be used in positive ways. So if one spectrum is full, then you must use another spectrum which is very much high in cost. So use it wisely, brother. Okay, technology challenge: connectivity increased vulnerability independent if wired or wireless. Delta requirement in a resource constrained system make PC-based security solution unsuitable. A non-linear amplifier have more than 50% efficiency while the linear amplifier does not. Okay, the difference between wireless and mobile. Wireless, going to talk about the wireless first. Later on, I will move to the mobile. Wireless does not mean mobile. Traditional computers or other non-mobile device can access wireless network. Wireless system provide a fixed or portable endpoint with access to a distributed network. The third difference between the wireless and mobile is the wireless is already a major way people connected to internet. The fourth one is the wireless gradually become more than just an access network. For instance, the Wi-Fi hotspot is a typical resource for someone who has relatively fixed device such as a laptop that doesn't have its own internet access built in. Whereas the mobile, it is a device. Device is one that is made to be taken anywhere. Mobile system offers all of the resources of that distributed network to something that can go anywhere, bearing any issue with local reception or technical area coverage. As for today, the mobile user tolerate disruption as they move, which means they were using it, they were expecting the best performance from the provider. As for tomorrow, user expect seamless mobility where they are expecting a better connectivity in the future. The example for the mobile section is a mobile device already have inherent access to the internet or other wireless system through those cell tower network that ISPs and telecom companies built specifically for them. So mobile device does not need Wi-Fi. They already have their connection. I think there is actually 7 of our question that is part of our tutorial, and feel free to write us a feedback throughout my explanation to you, and enjoy your life, brother. That's all. Thank you. Bye.